So our next presentation is MIPI, DisCo, and ACPI, Streamlining MIPI Component Integration. Robert Gough of Intel. Rob is a platform software architect with Intel Corporation. Responsibilities ranging from device and platform power management to I/O technologies, as well as OS and firmware interfaces. He's worked with industry specification bodies, including ACPI, UFI, and the PCI SIG for the last 16 years. He was a charter member and chief technical contributor of the MIPI Software Working Group, and he took over as chair of the Software Working Group in March of this year. So please welcome Robert Gough.
Okay. So it's 2:36. We're supposed to finish at 3:15. So I have lots of time today. Oh, and a nice big monitor down there. Okay, forward. So I came to talk about what we're doing in the MIPI Software Working Group and sort of a sales pitch. So I'm going to go over our working group charter. I'm going to give an overview of what's of ACPI a little bit, and talk about the implementation that we're using for MIPI through the DisCo process. I'm going to give you an example of how we're using this for SoundWire. I'm also going to talk about an open property database that's being developed in the adjacent industry. Talk about the benefits of using the DisCo properties that are being defined by the MIPI Software Working Group, and how you can use that to streamline your platform integration process. So first, our charter. We are given the task of coming up with a uniform mechanism for describing and configuring and enumerating MIPI components and devices. We are constrained with using an extensible framework, so something that we can use that is flexible, that can be applied to all of the MIPI interfaces that are defined today and moving forward. So we want to ensure compatibility with the specifications, interfaces that you guys are working on in other work groups, and also work with other working groups as they are building specifications in the forward process for up and coming interfaces. So another limitation or constraint we have is that we are not supposed to be increasing or placing a big burden on the hardware developers. So we want to minimize the amount of impact to gates, and also for software developers not placing burdens on how much. We need to limit the amount of software that needs to be written and code footprint as it's running on a host platform. And lastly, we want to provide an OS agnostic interface that can be used regardless of the operating system that you're running on. So this is the overview for ACPI. It's basically made up of three components. The top block on the left is platform independent software. So this is mostly your operating system software. So it's device drivers, controller drivers. We are relying on an ACPI subsystem, which includes an AML interpreter, and we'll talk a little bit about that. The next layer is the platform dependent software. This is the firmware that runs on the platform. It is specific to the platform on which it's running, so it has to be ported from platform to platform. And then, of course, all of these things are put together to make the underlying hardware work. So the platform-dependent software describes the hardware on the platform to allow the platform-independent software to use the hardware that's in the platform. The ACPI provides something called a namespace, which is a hierarchical view of the hardware platform, so sort of like a tree structure. That namespace is built by the AML interpreter as it consumes tables provided by the platform-dependent software, the firmware, and that's primarily these two boxes, tables that are provided by platform firmware, the differentiated system descriptor table and 0 or more subordinate system descriptor tables. So these tables are built during the system boot and are published in system memory and then consumed by the operating system as the operating system boots on top of this platform. The namespace, or the tables themselves that comprise the namespace are published in a format called AML, which is the ACPI machine language. And this machine language is built through a compiling process. So both the AML and the source language, ACPI source language, are described in the ACPI specification. If you haven't heard, sorry, I forgot to tell you what ACPI stands for. It is the Advanced Configuration and Power Interface. It's a specification that it's an open specification. It's been around since 1996 or so, and it is open, available for anybody to download. Okay. From a MIPI software perspective, the software working group has come up with a mechanism for device discovery and configuration, and we've called that the DisCo specification or mechanism. So we use mechanisms defined by ACPI, primarily the DSD or device-specific data object, to provide property sets to upper layer software, which would be your platform-independent software or OS layer. So encoded in this device-specific data object are two sets of information. There's platform-specific information and component-specific information. So the platform-specific information is around how devices are built within a given platform, how devices are connected, or features that are available only on, specifically on that platform. The component-specific information are properties related to the components themselves that cannot otherwise be discovered. So this would be the set of information that would be provided through a data sheet. It would be like clock rates supported on a given device. And those properties are optional. So you can build a driver that hardcodes all of the information that's in your data sheet so that it knows how to use these components. Or you could write a driver that is more portable and consumes this information from what's provided through DSD. One thing to point out, which is a big benefit, is that the properties that we're defining in the DisCo specifications through DSD are portable, which means they can be supported in non-ACPI environments. So I know some operating systems don't include support for ACPI and they rely on device tree instead. So there's a corollary between what we do in the ACPI DSD and what's done in device tree. So here is an example of information that's provided through DisCo for SoundWire. So this is an excerpt from the existing SoundWire DisCo spec, which is in draft process, in the middle of being published. So what you can see on the right is a SoundWire master device connected to 4 slave devices. This is certainly platform implementation specific information. It can't be detected by software probing devices to figure out how they're connected. So we have each device, SoundWire device, has multiple lanes. So you see that on lane 0 for each slave is connected back to lane 0 on master, which is a requirement for SoundWire. But you also see that in the yellow bar, lane 1 on slave 1 is connected to lane 1 on, lane 3 on the master, and lane 2 on slave 2 is also connected to lane 3 on the master. So the way that this is described through the DisCo properties is that we have a property key, which is a string in all cases, and a property value or a data payload, which in this case is a string. So within the data object or the DSD object for slave 1, it would include 3 properties describing the mapping for lanes 1, 2, and 3. So you see that lane 1 for slave 1 shows that it's connected to master lane 3. Likewise, lane 2 on slave 2 is also connected to master lane 3. The other thing that's allowed in SoundWire that we had to come up with a way to describe was that there are peer-to-peer slave links. So these are links that are connected from slave to slave and not back to the master. So we have 2 slave links that we're showing in this diagram, A and B, and the same property, lane N mapping, is used to show that they're connected to the slave links as well. So as you can see, these are specific to this platform in which these devices are built. So the next slide shows component-specific properties for the most part. And I wanted to point out that, again, we have strings as the property key, and then the different data types here We have some that are integers, some that are packages, and then of course in the last slide we also saw that there was a string value as well. A package is actually more of a combination of data so that you can have multiple objects within a package. So it's a collection, and they don't all have to be the same types. You could have a string and 2 integers and then even another package with more information, so you can pack things together in any format that you like. So the device-specific data information here would be that is specific to the component, not the platform, would include maximum clock frequency, as shown here. And that is shown as an integer value in hertz. Another way to describe information or similar information would be to provide a package of the property clock values or clock frequencies that are supported. And then this example shows different clock gears and actually gives an example of what a package of supported clock gears might look like. And then the last one is essentially an enumeration data type where we describe the type of port on a given device, where it can be a full data port, a simplified data port, or a reduced data port. And the upper layer software needs to know all of this information in order to be able to configure the platform to work optimally. So you could have this information encoded in the driver that is specific to the device, or you could provide it through the platform. So I wanted to switch gears a little bit and talk about a database. So as I said before, DSD can be used to provide MIPI-defined properties, and it can also be used to describe vendor-defined properties. So component vendors can define their own properties in addition to the ones that MIPI is defining. I did want to go back, sorry, and point out that the way that we're using these key values is that for all of the properties that we're defining within MIPI, we're using this MIPI prefix, and then all of these properties that we're showing here also come from the SoundWire DisCo specification. So we use another prefix or notation using SDW. So that wouldn't be necessarily true for vendor-defined properties at all. So a number of properties have already been defined and are in use in the device tree ecosystem. And there's concern that a lot of these properties are, there may be collision in how they're defined or how they're interpreted. So within the industry and the Linux kernel mailing list and the ACPI work group, there's a job where they are creating an open repository of a database that allows component vendors who have defined vendor-specific properties to publish those properties and formats for the data to an open database. So this allows sharing of this information to the developers who need to be able to consume this information. And then as we move forward and publish DisCo specifications through the software work group, we'll also publish the DisCo properties into that database. If you're interested in participating in putting properties into that database or want to find out more information about the hierarchy and how it's managed, there's a mailing list that you can join with the link there below. So the benefits to using the MIPI DisCo properties is twofold. The driver gains benefits because you can create a driver that is not platform specific. Before we defined architectural properties through DisCo, drivers had to be developed for a given single platform and then ported to different platforms. So that a driver written for a component on platform A would have to be modified and rebuilt to work on platform B. So then you have a whole bunch of drivers for the same component on different platforms. This means you're having to maintain all those drivers also. But with DisCo compliant drivers, you can write a driver once compliant with the MIPI specification, DisCo specification, and no longer have to fork drivers per platform. And then from the firmware perspective, the information that you're providing is OS agnostic. It's very simple to publish this information, and you can actually take property sets from component vendors and drop them in, so you don't have to spend a lot of time developing or reading data sheets, hopefully, if it all works together. So if we look at what the platform integration process should look like under my vision, component vendors will provide component-specific DisCo property sets, either in datasheet or preferably electronic format, to their customers. The platform designers will take those properties and build them into their firmware. They will add any of the platform-specific implementation properties as needed. And then the drivers that have already been written just work. There's no updates that need to happen. So drivers for new components that are developed based on DisCo specifications, they can continue to be reused. The only time you would have to update a driver is when there's an updated DisCo specification providing a new set of properties. Okay? So here's how you can help or enjoy the benefits. So if you're a component vendor, we want you to use the DSD properties that we've defined in the DisCo specifications. There's a typo on the next one. We want you to use those encodings that we've provided and publish those in your data sheet and provide those to customers. We want you to think about the properties that you are defining that are vendor specific and consider whether they might be applicable to other components. Maybe it's nothing special, it's just something that every device of your type needs and isn't already defined in a DisCo specification. And then if you think that's something that should be in the spec, then work with the software working group to get that into a subsequent revision of the specification that governs your component. And then if you have existing properties you've already defined that are being used in device tree, we would like to see those published in the DSD database also, so that the industry can, again, make sure that there isn't a collision between properties. And then, of course, provide your component-specific DSD packages, preferably in an easily consumable format, binary format, or text format, source code format to your your platform integrators. So if you're a system integrator, we want you to use the packages that are given to you by your vendors and drop those in, and then you just need to add in any of your platform-specific features. So if there are properties already defined for your feature or the thing that you're trying to define, don't go out and create your own. Look to see if there's one that already exists that matches what you're looking for. And going forward, we have a lot of work to do. We have a number of specifications on the list to get done, and we don't have a lot of people to do them. And we would really like to make sure that we are defining the right properties for the devices that are being created and the platforms that are being built. So we would like, if you're a MIPI contributor, we'd like you to join the software working group and help us make sure that what we're doing is right and meets everybody's needs. Okay? I zipped through that pretty quick. Any questions?
Any questions for Robert?
Okay.
All right, then. Thank you.
Thanks. Oh,
Thank you.